Our solar system is full of alien worlds, planets and moons with landscapes, atmospheres, and mysteries waiting to be unraveled. Imagine soaring through the swirling clouds of Jupiter, larger than all the other planets combined. Picture the icy rings of Saturn, a celestial ballet of rock and ice. These are not just distant points of light, these are places, worlds unto themselves, each with its own story to tell. Now, we're on the cusp of answering the question of whether we are alone, right here in our cosmic backyard. When we say alien, we don't mean little green men or flying saucers. We're talking about environments so different from our own, so extreme, that they challenge our very definition of what a habitable world can be. Take Venus, for example, our closest planetary neighbor, similar in size and mass to Earth. But Venus is a stark reminder that appearances can be deceiving. Shrouded in a thick, toxic atmosphere, its surface is a scorching inferno, hot enough to melt lead. Or consider Mars, the red planet, a beacon in our night sky. It's a frigid desert world, but we see tantalizing clues of a wetter, warmer past, dry riverbeds, polar ice caps, and evidence of ancient lakes. Could life have once existed on Mars? Could it still be clinging to existence beneath its rusty surface? And then there are the gas giants, Jupiter and Saturn, ruling over their own mini-solar systems of moons. These moons aren't just chunks of rock and ice. They are worlds in their own right, some harboring hidden oceans beneath their icy shells. These are just a few examples of the alien worlds that await us in our solar system. Each one is a unique laboratory, a chance to study the forces that shape planets and the potential for life to arise in the most unexpected places. Venus. The name conjures images of beauty, the Roman goddess of love. But don't let that fool you. Venus is a planet of extremes, a cautionary tale of a world gone wrong. Imagine standing on the surface of Venus. You'd be crushed by the atmospheric pressure, 90 times greater than Earth's, like being thousands of feet beneath the ocean. The air itself would be unbreathable, a toxic cocktail of carbon dioxide laced with sulfuric acid clouds. And the heat, over 900 degrees Fahrenheit, hot enough to melt lead. This is the reality of Venus, a runaway greenhouse effect gone wild. But was it always this way? Scientists believe that Venus may have once been a much more hospitable place, with oceans of liquid water and a temperate climate. But something happened, turning it into the scorching hellscape it is today. Was it a massive volcanic eruption that spewed greenhouse gases into the atmosphere, or a gradual warming caused by the sun's increasing energy output? We don't know for sure. Despite its harsh conditions, Venus continues to fascinate us. Spacecraft have pierced its thick clouds, revealing a landscape sculpted by volcanoes and ancient lava flows. We've mapped its surface, revealing vast plains, towering mountains, and even evidence of tectonic activity. By studying Venus, we can learn more about the forces that shape planets and the conditions necessary for life to arise. Mars, the red planet. For centuries it has captivated our imaginations, a symbol of adventure and the unknown. But Mars is more than just a point of light in the night sky. It's a world of stark beauty, a frigid desert with secrets buried beneath its rusty surface. Look closely, and you'll see signs of a past far different from the Mars we see today. Giant canyons carved by ancient rivers, vast plains once submerged beneath oceans, polar ice caps holding frozen water and clues to Mars's past climate. Today, Mars is a cold, dry desert, its thin atmosphere offering little protection from the sun's radiation. But we've discovered evidence that liquid water may still exist on Mars, flowing deep beneath the surface. And where there's water, there could be life. We've sent rovers to Mars, robotic explorers that have traversed its surface, analyzing rocks, drilling into the soil and searching for signs of past or present life. We found tantalizing hints, organic molecules that could be building blocks of life, but no definitive proof, yet. The dream of sending humans to Mars is no longer science fiction. It's a real possibility, a goal that drives us to develop new technologies and push the boundaries of human exploration. Imagine standing on the surface of Mars, feeling the red dust beneath your boots, gazing up at a pink sky. Imagine the thrill of discovery, of being the first humans to set foot on another planet. Mars is a challenge, a test of our ingenuity and our spirit of exploration. But it's also a promise, a chance to unravel the mysteries of our solar system, and perhaps even answer the question, are we alone? Jupiter, a colossal giant, a swirling vortex of colorful clouds larger than all the other planets in our solar system combined. Jupiter is a gas giant, a massive ball of hydrogen and helium with no solid surface. But don't let that fool you into thinking it's a boring, featureless world. Jupiter's atmosphere is a maelstrom of storms, including the Great Red Spot, a hurricane-like storm that has been raging for centuries. But Jupiter's true wonders lie in its moons. Over 79 moons have been discovered orbiting Jupiter, each one a world unto itself. There's Io, the most volcanically active body in our solar system, its surface constantly reshaped by eruptions of molten sulfur. And then there's Europa, a moon covered in a smooth icy shell. Scientists believe Europa hides a vast global ocean beneath its icy exterior. NASA is planning a mission to Europa, searching for signs of organic molecules and perhaps even evidence of life itself. Jupiter and its moons are a microcosm of the solar system, a diverse collection of worlds that challenge our understanding of what's possible. Saturn, the ringed planet, a celestial jewel box adorned with countless icy particles. But Saturn's rings are just the beginning. This gas giant is home to a collection of diverse moons. Among them are Triton and Enceladus, captivating scientists with their potential for life. Triton, Saturn's largest moon, is a world of strange beauty. It's the only moon with a dense atmosphere obscuring its surface. Through the haze, we've glimpsed a world both familiar and alien. Triton has lakes and rivers, but they're filled with liquid methane. Could life exist in Triton's methane lakes or beneath its icy surface? It's a question scientists are eager to answer. Enceladus, a small icy moon, is full of surprises. It spews plumes of water vapor and ice from its south pole. These plumes come from a vast ocean beneath its icy shell. The plumes contain organic molecules and salts, hinting at life. Enceladus is one of the most promising places to search for life. Triton and Enceladus are just two of Saturn's many moons. Together they paint a picture of a diverse and fascinating solar system. Neptune, the eighth planet from the Sun, a blue giant shrouded in icy clouds. It's a world of extremes with supersonic winds and temperatures that plummet to hundreds of degrees below zero. But even in this distant realm where sunlight is 1,000 times fainter than on Earth, we find wonders that defy imagination. Triton, Neptune's largest moon, is one such wonder. Unlike most moons in our solar system, which orbit their planets in the same direction as their planet's rotation, Triton orbits Neptune in the opposite direction, a retrograde orbit. This suggests that Triton wasn't formed in Neptune's orbit but was captured from the Kuiper Belt, a region of icy bodies beyond Neptune. Triton's surface is a canvas of icy plains, nitrogen glaciers, and cryovolcanoes that erupt with plumes of nitrogen frost. These features suggest that Triton is geologically active, a surprise given its small size and distance from the Sun. What powers Triton's internal heat engine? Scientists believe it could be tidal forces from Neptune or perhaps radioactive decay in its core. Triton is a reminder that even in the coldest, most distant reaches of our solar system, nature finds a way to create worlds of wonder and beauty. It's a testament to the power of exploration, to the endless capacity of the universe to surprise us. So, what have we learned from our journey through the solar system? We've seen scorching landscapes on Venus, where the very air is a deadly cocktail. We've explored the rusty plains of Mars, searching for signs of ancient life. We've dived into the hidden oceans of Jupiter's moons, where life might be swimming beneath miles of ice. We've witnessed methane rain on Triton and ice volcanoes erupting on Enceladus. We've even journeyed to Triton, where nitrogen glaciers flow across a landscape sculpted by cryovolcanoes. Each of these worlds is unique, shaped by its own particular history and circumstances, but they all share one thing in common: they are alien. Not in the sense of little green men or flying saucers, but in the sense that they are profoundly different from our own planet. These alien worlds challenge our preconceptions about what a habitable planet should look like. They remind us that life, if it exists elsewhere in the universe, might take forms far stranger than we can imagine, and they underscore the importance of exploration, of pushing the boundaries of our knowledge and venturing into the unknown. These planets and moons are more than just distant rocks. They're windows into the universe's creativity, waiting for us to explore and discover their secrets. Each mission, each probe we send, each image beamed back, expands our understanding of the cosmos and our place within it. The quest to understand these alien worlds isn't just about scientific curiosity. It's about unraveling the story of our solar system, a story that began billions of years ago and continues to unfold today. And who knows, perhaps somewhere out there on a world yet unexplored we'll find evidence that we are not alone.